You've probably seen a rocket launch, at least on YouTube. Obviously, these huge plumes of fire push the rocket upwards. But why? How do rocket engines push such a massive vehicle upwards? How come they can even work in space when there's nothing to push against? So these questions confuse a lot of people because nearly all the objects around us move by pushing on something. A runner pushes off the ground to move forward. Your car tires push on the ground. Birds flap their wings. Yeah, we all push on stuff, except what do rockets push on? Well, this gets a little bit tricky because rockets don't actually need to push on anything. In fact, they can operate more efficiently in a vacuum. If this is a little confusing to you, don't worry, it also confused the New York Times in 1920. This is when Robert Goddard, the father of American rocketry, first published his idea that a rocket could fly in space and even to the moon. The New York Times released a completely wrong editorial lashing out at Goddard and his idea that rockets could travel in space. They said that Professor Goddard, with his chair in Clark College and the countenancing of the Smithsonian Institution, does not know the relation of action and reaction, and of the need to have something better than a vacuum against which to react. To say that would be absurd. Of course, he only seems to lack the knowledge ladled out daily in high schools. This seems a little bit harsh for the father of American rocketry. So if a rocket doesn't need anything to push on, what's actually going on? Well, I'm sure some of you have seen your garden hose whip around, and if you haven't, maybe you've let go of a balloon just to watch it fly around the room. Well, why does it do that? In the balloon example, the air is being pushed out by the balloon, and according to one of Newton's laws, every action has an equal and opposite reaction. So if the balloon is pushing on the air, then the air is also pushing back on the balloon. So the air in the balloon is coming out with enough speed that it pushes the balloon around. Now, obviously this isn't very much force, but the balloon doesn't weigh very much, so it doesn't need a lot of force to move around. Same thing is going on in the hose example. Water is coming out of the hose so fast one way that the hose flies the other way. Both of these examples would still work in a vacuum. Rockets are basically the same thing as a balloon, except obviously they weigh a lot more. So rockets need to push out a lot more gas way faster than a balloon could. And instead of latex to hold in pressure, rockets use high-strength materials. Then scientists can amp up the power even further by using specially shaped nozzles, super hot combustion gases, and extremely high-pressure flows. As long as the thrust from the engines is greater than the weight of the rocket, the vehicle will move upwards. Is that a little simplistic? Yeah, but now you know.